So for our circuit, we were assigned an Astable Multivibrator with variable frequency output driving an LED. So how we set that up is we have 5 volts, which is going through a set of resistors and a photoresistor to a capacitor, which is changing the amount of time it takes for the capacitor to charge and discharge. That 5 volts is also powering a 555 timer chip, which has an output of a 470 ohm resistor and an LED going towards ground. So how this circuit works is as you put your hand over top of the photoresistor, the resistance increases, causing the amount of time it takes for the capacitor to charge and discharge to increase. But as you remove your finger, the photoresistor gets more light and it takes less time for the capacitor to charge and discharge. For our calculations, the first one, we calculated the voltage drop through the resistor before the LED. So the current output by the 555 timer, looking at our circuit simulation, was approximately 6.9 milliamps. So according to Ohm's law, in order to find the voltage drop, it's equal to current times resistance. Well, we know that the resistor is 470 ohms. So if I take that 6.903 milliamps times 470 ohms, it's approximately a voltage drop of 3.244 volts going through that resistor. And that makes sense because if we subtract 3.24 volts from 5, get approximately 1.7, and that's the amount of voltage it takes to power a red LED. Going over the second calculation, we did the time it takes for the capacitor to charge when the photoresistor is at 54.5 k ohms, which is about half brightness. So for the time constant, it's equal to resistance times capacitance. Well, if it's 54.5 kilo ohms multiplied by 100 microfarads, so it's 54.5, then you multiply that by 1,000 for kilo ohms, and then you have to take into account microfarads, which is 10 to the negative 6. So you multiply 100 times 10 to the negative 6, which gives you 0.001 farads. Excuse me, 0.0001 farads, which gives you approximately 5.45 seconds it takes for the capacitor to charge and discharge.
Alright guys, so I'm going to explain our physical circuit here. So this is our 5 volts coming in from our board, which then runs to our resistor, then our photoresistor, and then our capacitor, which then powers our LED light bulb that goes with a 470 ohm resistor. When we cover up the photoresistor, it gets more resistance, which makes the LED blink slower. Once the LED is fully covered, it should take about 5.4 seconds totally on and off. Okay, so now for this part. Don Ruba had us go through, leave the classroom. He put an actual bug in our circuit without us knowing. When we came back to the circuit, there was no power to the circuit, the light stopped blinking. We had no clue what was going on, so we went through some steps on how to troubleshoot our circuit. First thing we did, we tested the voltage coming in from our positive and negatives. Well, we found that there was no power even getting to our board. So then I would look closer at this wire right here, and it looked like someone has tampered it. Well, Don Ruba pulled out this wire and it was no longer connected in the circuit, which gave us no power.